represent a point, but a vector has both magnitude and what's the other one? Direction. The typical axis, if we start at the origin, and let's just say that is 2,2 at the point. If you wanted to write it in vector notation, you would write it as okay, so all that's the kind of like what's the other one? That's what physicists want, and that shows up in calculus too. But eventually, when we go to object later on, we will see matrices and start to use that. Perfectly fine. And if you took the magnitude, what would the magnitude be? You have the vector, what is A? 2. What is B? 2. So how do we find the magnitude? Square root of what? A squared plus B squared, and in this case, it would simply be square root of 8, which is 2 times root 2. Pretty much the length of the diagonal. Square. Here, the length of the side is just 2. Great. Now, you don't have to necessarily start a vector origin. For example, I could go to 1, 3. Yes. And could be 3, 5. As a vector, how would you write it? 1, 3 in terms of I and J. Okay, 3I plus 5J. What about here? I plus 3J. Or you could use the square bracket notation. If we want to look at just the distance between those two, what we can do is write it this way. 3 minus 1, 2 by vector. Yes. Plus 5 minus 3 J vector. Good. And that would give you 2I vector plus 2J. Going to call the points as x1, y1, and x2, y2. And I get a resultant vector, which is simply x2 minus x1, y2 minus y1. Yes, that's exactly what I did. 5 minus 3 is y2 minus y1, 3 minus 1 is x2 minus x1. I end up getting the resultant vector, which is 2I vector plus 2J. if I want to find the magnitude of that, what would the magnitude be of all these W? What is the magnitude? Square root. Okay. So we have two vectors, but they have the exact same magnitude. Two different vectors, same magnitude. Typically, we start a vector at the origin. This formula that I have a magnitude, I'm going to write it in terms of x2 and x1, and you can tell me what that reminds you of from algebra. Hope. Good. Magnitude, square root of that. A squared. A is to which we got from x2 minus x1. B squared to y2 minus y1. Yes. Can't say.
It's the distance from
It's simply the distance between 2 points. Correct? So pretty much, or not pretty much, the magnitude is nothing but the distance that we observe between 2 points, between two vectors. And specifically, we call this a two-norm non-startable magnitude. We want it one norm. That makes sense. And anything that you do with points, numbers, you can do with vectors also. So in this case, I want to add the two vectors. So A plus W. Good. Which will give me I vector plus 3j vector plus 3i vector minus 2j vector. If you forget the i's and the j's for a moment, well, we can't. If you combine the i's, if you combine the j's, what do you get? The I is. That's an easy question. 4i vector. And over there, 3j minus 2j. J vector. Good. Good. Where is the first vector? And where is the second? And where is the vector after you add? I want you to draw them based on what we know thus far. I have 3 vectors. I want you to draw those 3. So I mentioned, what do you do with numbers? So what reflectors? All means you're just writing numbers in higher dimension. If you think of a number, the number is just a vector in one dimension, like just the examples, or just the y-axis. So the original vector, that's 1, 3, right over there. And it's 0. That is D. And the other one, 3I minus 2J, it's right there. W. And the resultant vector is 4 and 1 there. 3 plus W. Good. In physics, you learn something called parallelogram normal form. Didn't think we would have this stuff, so let's go in time. Yes. Now you may ask, well, why do we have? Again, it's sort of easy to see things in 2 dimensions, but if you extend to higher dimensions and we want to make the math work, then we've got to understand it in 2 and 3 dimensions. What can I say by looking at the value? I have the, and so something's going that way, something's going this way, and you're adding, could be whatever. And you're simply adding them in what direction they're going that direction. Good. Great. Addition, if you change the plus sign by a minus, you get subtractions. Yes. If you add 2 numbers, 2 plus 3 is the same as 3 plus 2. Right. If I switch the order, we will get a different answer. In other words, instead of doing B plus W, if I did W plus B, will I get a different answer? No, not the same. The 0 vector in any dimension in 1 dimension, it's simply a number 0. Yes, if you want to put a bracket, you can't. Or you can write it as 0 times I vector. In 2 dimensions, dots. 0 vector, in other words, I'm referring to the origin in 2 dimensions. What is that vector? 0 I plus 0 j. Or I can write it as 0. Yes. Another case is 3D. 0 vector in 3D would be 0, 0, 0. It might seem silly, but again, we're trying to translate things from 1 and 2 dimensions to 3, 4, 5, and so on. Right, naturally, we have addition, subtraction. What do you think? Multiplication. So we've got to be careful when we do multiplication. There are 2 types. One is vector multiplication, the other is scalar multiplication. So the first case that I'm going to do is scalar multiplication. And you may say, well, what is a scalar? A scalar is just a number with no direction. A vector with no direction. In other words, it's just a magnitude. It's a value. So, what does scalar multiplication mean? If you take a vector and you multiply it, say, by some number, pick one. Should we use V or W? W. And that is my vector. I want to pick a scalar. I don't want to use I or J or K or A or B. So I want to multiply the vector W, which has a direction. By all means, those vectors that I wrote should have a direction. I'm sure you realize that that is correct. Multiply C by W. Your book will denote a vector in bold notation. Have a bold text. 2 times W. Think of it as if you're distributing. Well, if you distribute, what do you get? Six I vector minus 4J vector. So cheap. I know where things go. So, fully drawn. So I have the vector, the first one is W, 3I minus 2J. Now I multiply it by 2. That is the total vector. Yes. So you simply extended the length of the vector by 2. Yes. Twice its original length. I want you to take V plus W, multiply by a scalar, but use the scalar C to be -1. Sketch it and tell me what you get. Do you follow what I said? So take the vector V plus W, and we're going to multiply by a scalar C. And the value of the scalar is -1. Good. Once you do that, go ahead and graph it. Tell me what it is. I'll come and check. So, if I take V plus W, I'll call it U, which is also a vector. The value of U is 4I vector, or 4I plus J. I'm referring to vectors. Want to multiply it by a scalar, say this thing distribute the negative 4 vector minus 0. Good. So x is negative 4. Okay, I'm going to choose. No, not bad actually. What just happened to the vector? Did it just extend? Over here, it extended. Oh, something else happened. Went to the other side, in other words, it flipped and changed direction. Good. So anytime you multiply by a negative scalar, you are going to change the direction of the vector. Good. Okay.